This is our first lesson for AP Stats, Chapter 1, Lessons 1 and 2. A couple guiding questions I'd like you to keep in mind. What are different types of variables, datas, and distributions we can use to learn more about a data set? So what's involved in these? Here we have the distributions of guess times for how long a minute is from block 2 and from block 5. Remember that each dot represented one guess, so one data point, and this can tell us the values that the variable takes, which is guesses, so you mean the number of seconds in your guess, as well as how often it takes it. So you can see that, for example, in block 2 up here, we had 1, 2, 3 students who guessed 62 seconds. So individuals are objects described by a set of data, and variables are the characteristics of them. We have two types of variables, categorical and quantitative. Categorical variables would be like color. Quantitative variables involve quantities or numbers and take numerical values. All year long we'll be talking about distributions. A distribution, knowing what it is important. It's the values that a variable takes, how often it takes those. Looking at these things, we're going to look at ways to draw inferences. So how can we take the data we have and apply it to a larger group? How can we determine cause and effect between two types of an explanatory and a response variable? And those are things that we're going to explore more over the course of the year and in Chapter 4, but randomization is key to those. So different ways we can represent data and distributions. Dot plots, that's what we use there in class. A stem plot, we'll look at some examples there. These are a little more antiquated and they're still useful if you're doing something quick by hand, but they're my least favorite of all. Box plots are a nice way to look at data as well. We're going to get into those a lot more in Lesson 3. And then there's bar graphs and pie graphs, which you're likely familiar with. Histograms are different from bar graphs, that they're for quantitative data, not categorical data, and that the bars tend to not, for continuous variable, where all values of a variable can be taken, those bars would be connected. A density curve is like drawing a smooth curve over those. So bar graphs and pie charts tend to be a little more straight ahead, as people have used them a lot in elementary school. You always want to see what type of data representation is most appropriate to show whatever it is you're trying to illustrate. A pie chart could be very helpful for some data, but not for others. For example, if things don't sum to 100%, then a pie chart might not be the best option, like how many people are in a math class, and if somebody's in more than one math class, things might not necessarily add to 100%. Pictographs are often used in commercials, and you may have seen them there. The one thing we need to know about pictographs is that this two-dimension aspect of them makes them deceptive. So the size of this DirecTV versus Dish Network here is much bigger than the difference between the two values. So the height is really the only thing it's showing, but it's making the area much bigger as well. So it's deceptive. It's making this value seem much, much bigger than this one when that's not really the case. So they're not an objective display of the data. So two-way tables we can often use to represent variables, data with more than one variable associated with it. So if we had guesses and gender, so length of guess and gender, or actually two categorical variables, and we want to find an association between them. So if we had guesses underestimate, overestimate, and male and female, to see if it was an association between being male or female, between gender and length of guess. Here we have superpower preference and gender. And between these two categorical variables, we have counts, and we can see if, for example, your gender makes you more or less likely to choose a certain superpower. We can see a large difference between the females and the males for super strength, for example. So that's an example of a two-way table, two meaning the number of variables, so superpower, gender. And a conditional distribution would mean given values of one. So given that you're female, what's the probability that, or what's the likelihood that you choose super strength? Well, given that you're female means cover up the male column, cover up the total column. 3 out of 115 females chose super strength. That is a conditional distribution. Males would be 17 out of 85. So we can see, given the total here, that difference is even more significant because there were less males and quite a few more answered super strength. A marginal distribution would just be saying how many people chose invisibility, so values of one variable. So we'd look at total columns, 30 over 200. That's a key thing and tends to be one of the most difficult concepts in lessons 1.1 and 1.2. So a marginal distribution, remember, values of one variable. So we're going to cover up the inside of our table. We just want to know if it was for gender, we'd be looking at 115 over 200 for females, 85 over 200 for males. So this will always be our denominator down here for a marginal distribution. If it's a conditional distribution, we're saying given that you answered freeze time, so I'd cover up everything except for this row right here. So I'm just looking here and I'd say 20 over 52. So given that you said freeze time, what percent were female, what percent were male? That's a conditional distribution. We stay away from the terms independent and dependent variable because independence means something different with statistics. So we use the words explanatory and response variable. Explanatory, X being graphed on the X-axis, response being graphed on the Y-axis. To organize our problems throughout the year, we will use the state, plan, do, conclude method. This would let anybody else take your work, or if you're doing real work outside of the classroom, you would state the problem you're trying to answer, you'd show that the conditions are met and kind of plan out what you're going to do and which calculations would be appropriate. You'd carry them out, and conclude means put that into words in terms of answering the question you stated. So this will come up throughout the year. So state, plan, do, conclude is an important thing to remember. The way we plan and do a problem will change depending on what we're studying, but that will be an important thing to know. In association, I mentioned this earlier, if values of one variable seem to occur with values of another. So for example, we saw that male and superstrength, there seemed to be a potential association. So we're going to look at quantifying what that might be. So being male seems to lead you to be more likely to choose superstrength. Did that just happen by chance, so chance variation? Or is that such a big difference that it shows that there's an association between gender and superstrength? Do not worry about Simpson's paradox, not on the AP exam, so we're not going to cover it. Bit interesting if you'd like to read up about it. I would like you to now pause to read over our multiple choice question. So on the Google form, which has a button right below for the homework, you're going to click on that button and you're going to answer A, B, C, D, or E. So what is meant by a distribution and how can we represent a distribution using a dot plot? So please pause right now. Read your 5 answer choices and then answer on the Google form. Okay, here's an example of a stem and leaf plot. This is from How Long is a Minute from a past class. Stems here represent the tens column. Leaves are the ones column. So the 7 and 6 here represents 76. So if you turned your head clockwise or to the right 45 degrees, this would be like looking at our dot plot. And you could see the peak that most of the values occur in the 40s. So this row would be everything from 40 to 49, this from 50 to 59. So one way to represent your data and get a good idea of the shape, center. So shape is the overall shape it's taking. Does it look symmetric or not? Center, what's the median or mean? Any potential outliers, anything that's out of the overall pattern, which could be this one, although it may not be. And then the spread, how spread out your data is. We use dots for these in class. Here it just uses actual particular values, so they have different uses. Splitting stems happens when we separate in the ones column, the 0 through 4 from the 5 through 9. So here this would be 30 through 34, here 35 through 39, and so on down. It can give us a better picture of the overall data set. Let's say our data only varied from 29 to 41. If we just did it without splitting the stems, then it would all be basically in one area. So sometimes, depending on our data and the range of our data, splitting stems, so instead of going from 30 to 39, we go from 30 to 35, values included here. This means there's 3 values from 35 to 39, and those values are 35, 38, and 38, and so on. So this is splitting stems. So as we go through this, it's a good idea to pause, and if something's confusing, get an idea of your book. It also has a different description of what's going on. Here's lesson 2. We're jumping into quantitative data with graphs. So what are dot plots, stem plots, and histograms? Remember your SOCs. That's the four aspects of a distribution. So remember your SOCs: shape, outliers, center, and spread. And those are the 4 qualities of a distribution we use to describe it. So dot plots, each data value is a dot above its location. We saw what stem plots were and how that works. We can do back-to-back stem plots where one data set goes left and one goes right. If I wanted to compare block 2 to block 5 with a stem plot, that would be a good way to do it. Generally, we could also do that with a dot plot, one on top of the other, where their x-axes are lined up. So that's the idea of stem and leaf plots. Here is an example of a histogram. Now, instead of dots, here this means from values equal to 60 and greater, but less than 65. There's 3 of them. The frequency is on the y-axis, just like a dot plot, but each of those are becoming a rectangle. This means values between greater than or equal to 65, but less than 70. And there's 3 of them. So this tells us frequency just like a dot plot, but if we turned each of those little stacks of dots into a rectangle, it becomes a histogram. So again, a histogram, the difference, we have quantitative variable here on the x-axis. We don't have categories. We don't have freshman, sophomore, junior, senior. Here we have values, quantities. The bins should be equal sizes, be quantitative variable. There's usually isn't gaps, although sometimes you'll see some gaps. We'll also sometimes, if we don't have a continuous variable, like if we have a variable that was like shoe size, where you're either 10, 10 and a half, 11, you might see these bins separated and you might see the bin right over the value, although that's would only be as effective if you had a discrete variable where it only took on certain values and not values in between. Okay, symmetry. The shape, we use symmetry to describe it. So approximately symmetric distribution would be like we can put a line down it and it looks like a mirror image on the left and right. Skewed right means there's a tail down to the right, and it skews the mean to the right because this value weighs in more on the mean than a value closer to it. Skewed left, we'd have that tail going off left because these values are affecting the mean more than values that are close to typical values. So outliers are values that are out of the overall pattern of the distribution will tend to skew the mean and make it a worse measure of center. So as we move on, we're going to look at that in more detail and in class. But right now you should know approximately symmetric. If it gets worse than this, but there's still some symmetry, we can say roughly symmetric. And then skewed right and skewed left. The other one we have is uniform, which looks like a flat line right across where all the values occur at the same amount of frequency. And then we can describe the mode. So the peak is part of the shape. Unimodal, there's 1 peak. Bimodal, there's 2. Multimodal, 3 or more. We describe where the mode is. So looking for an overall shape, that's what we say, remember your socks. The shape, you want to look at the peak. Is it skewed right? Is it skewed left? Is it symmetrical? Is it uniform, meaning flat all the way across? Measures of center, we could use the median, the middle number when you order them from least to greatest. The mean, if the shape's more symmetric, and there's a reason why we want to use the mean as we go forward. Outliers fall outside the overall pattern of the graph. You don't have to quantify them now. In lesson 3, we'll learn how to determine if something's an outlier using the rest of the data set. Right now, you just have to know they stand outside the overall pattern. Spread, one measure is range. We'll look at IQR as we move forward. Right now, I want you to know that's how spread out the data is, and the range is the max minus the min. We'll look at how to calculate this in lesson 3. You don't have to worry about that for our first quiz. We can use standard deviation, which we'll also look at in lesson 3. If I ask you to compare 2 distributions, then I'm asking you to compare individually their shapes first. So the shape of this distribution 1 is symmetrical, while the shape of distribution 2 is skewed right. Then their centers, then the spread, and then the outliers. Don't do them separately. You want to compare each aspect individually. Okay, now's a good time to pause. Read through the summaries in your book of 1.1 and 1.2. You can look at the outline online I have as well. And I want you to describe the shape, outliers, center, and spread of the following distribution on the Google form. And then ask any question you may have. And for thinking about how you might use this for your project, just do the best you can with that one as we're just fleshing out what your project idea might be. So here's the distribution. You're filling out that free response. Keep in mind you have 1 time to submit your question, so make sure you're good with the submission. And always click to send me a copy of my responses. That way you have confirmation that you turned it in.